Hi everyone, welcome to Flow Academy. In this class, we will talk about two methods of calculating derivative, which are the chain rule and implicit differentiation. First, let's talk about the chain rule. This is the basic form of chain rule. And this is, you don't have to recite it because when you understand the reason why this could appear, you have already mastered the use of chain rule. Here is an example of chain rule. Y equals to sine 3x squared plus 1. We want to find dy dx for this function. First, we try to use the 22 basic derivative formulas, but that's not possible because it doesn't fit any of them. However, we could still see something familiar in this function. We know how to calculate sine x and 3x squared plus 1. This kind of function is called composite function. Which has an inner function and an outer function. Here the inner function is 3x squared plus 1, and the outer function is sine. We separate chain rule into 3 steps. Step 1. We need to define an u. So here let u equals to 3x squared plus 1. And we replace 3x squared plus as u. 3x squared plus 1 as u. So we get y equals to sine u. Step 2. We calculate the derivative of both this and this function. Du dx equals to 6x and dy du equals to cosine u. Please be cautious about the second one because we are calculating derivative about u, so this is dy du. And step 3. We use the basic form. It's really easy to understand. We times these two functions together and du dx times dy du. And then we could eliminate du and remain dy dx. So in this example, the answer will be 6x times cosine u. And in the beginning, we let u equals to 3x squared plus 1. So we now put it back. So the final answer is 6x cosine x 3x squared plus 1. So the final answer dy dx is equals to 6x cosine 3x squared plus 1. Remember, you need to put the original form of u back to the answer because you defined u, so u can't be appear in the final answer. Now we continue talks about the second method, which is the implicit differentiation. When we face some functions which you could not put a single y on one side of the function, you use implicit differentiation. Here's an example. 3x to the 3 square plus to the third square plus y to the third square minus 9xy equals to 0. When the question asks you to find dy dx in this function, it's not the same as the function we've met before. Firstly, we calculate the derivative of both sides. And then each of the small sections, like this. In the left, the derivative of x squared at x to the third square. In the left, the derivative of x to the third is 3x squared, using the method we've mentioned in the first class. The second one d dx y to the third square, we can't directly calculate this, so we use chain rule. First, we let u equals to y and t equals to u to the third square. And then follow step 2, calculate the derivative of each one. Du dx equals to dy dx. And dt du equals to 3u squared. Then step 3, we replace u using y. And then times these two together. And so here is dy dx times 3y squared. And now we get to the last one, 9xy. First, we take out 9 because, as the third rule says, the coefficient doesn't affect the answer. So the 9xy will be then use the rule of multiplying to separate it into the derivative of x times y plus x times the derivative of y. The derivative of x is 1, and the derivative of yx is dy dx. So in the end, it will equal to 9y plus 9x dy dx. In the So now let's get to the right part of the equation. The derivative of 0 is 0. And so because we would like to calculate dy dx, so we put all those with dy dx on one side and the other on one side. And we move these things and to the same side and get dy dx equals to 3x squared minus 9y divided by 9x minus 3y squared. And we simplify it into x squared minus 3y divided by 3x minus y squared. The hardest part of implicit differentiation is the part we're calculating things about y. And you may watch that part several times after you get that. And that's all for today. Thanks.